All right, in example 4, we're going to solve the system of linear equations with a matrix equation. All right, so I'm just going to take this system of linear equations. I'm going to write it in matrix form. I'm going to write the set of a matrix, write the matrix equation for it. So I'm going to get -3, 2, -1, 2, -1, 2, and let's see, it looks like the x term is 0 here, 1 and 5. And then that's times x, y, z, right? That's our variable equation. And the result is 5, -5, -7. Okay, so this is our A matrix, this is our X matrix, and this is our B matrix. And we want to solve for X, right? The X matrix. So what we're going to do is we're going to take that X matrix, right, which is X, Y, and that's going to be equal to A inverse times B. Now, A inverse is the matrix from example 2 that we verified. So from example 2, we found that the inverse of this matrix A is, what was it, 7, 11, -3, 10, 15, -4, -2, -3, 1. Okay, so we verified in example 2 that that is the inverse of that. So that's convenient. We have the inverse. The trick is finding the inverses, and we're going to talk about that in a bit here. So if we have the inverse, we can just multiply by this result matrix B, and we'll get the solution. All right, so 35 minus 55 minus 21. Okay, that's a lot of arithmetic. Here, I'll just write it out so you can see what I'm doing. 55 plus 21. Okay, that would be the first element. And I can write the result, because if I do that arithmetic, I get 1. Okay, then I'm going to get the second row, first column. So it's going to be minus 50. Oops, no, not minus 50. 50, right? Because it's 5 times 10. So 50. And then -5 times 15 is a -75. And then -4 times 7 gives me, it should be minus 28, right? Minus 28. I just realized it's supposed to be a -7, right? Because I got a -7 here, a -7 over here. All right, so actually this is plus 28. All right, so then you get a 3 when you add that up. And then finally the third row times this first column is going to give you -10, and then plus 15, and then -7. All right, add that all up, and I got a -2. All right, so this is telling me that x is equal to 1, y is equal to, whoops, this should have been x, y, z. Y is equal to 3, and z is equal to -2. Okay, so we can check that. We can check that against our original equations, right? We'll just plug it in and make sure that we got it, because it's so easy to make a little arithmetic mistake in these problems. So we might as well check it. So -3 times 1 plus 2 times 3 minus minus 2, right, gives me 5. It should give me 5. So yep, that looks like it works. All right. The next equation is 2 times x, which is 1, minus y, which is 3, and then what is it? Plus 2 times -2, and we should get a -5. So does that work? Yes, it looks like that'll work. Good. All right, and then finally we have y, which is 3, plus 5 times z, which is -2. And that should be equal to -7, and it is. So we have a -10 plus 3 gives us -7. So it all works. All right, so we just solved another matrix equation using an inverse. The next thing we're going to look at is how we calculate the inverse. How do we find the inverse of a matrix? So I'll meet you in the next video to talk about that.